In order to remember the structure of purine and pyrimidine, first of all, you have to remember that pyrimidine is a one-ring structure and purine is a two-ring structure. We know that pyrimidine is composed of three nitrogen bases: cytosine, uracil, and thymine. So you have to remember in the order cut so that you will be understanding the structure well. And there are two purines, which is adenine and guanine. Now let us see the structure of pyrimidine. So in order to remember the pyrimidine structure, you have to first know the basic structure of the basic ring structure of the pyrimidine. So it is having a six-membered ring, and this structure will be common to all pyrimidines. So this particular structure will be common to all pyrimidines. So let us see the three of this particular structure in order to represent the three pyrimidine. Double bond O, and then one more thing, N, double bond O. So this particular thing is happening in such a way that cytosine is converted into uracil, and which is then converted into thymine. So that's why cut. I told you to remember the cut. Cytosine is forming the uracil, uracil is forming the thymine. A cytosine can be converted into uracil by the process deamination. Uracil can be converted into thymine by the process methylation. So as the deamination should happen, cytosine is having amino group. So you can remember the fact that cytosine is having amino group if you are remembering cytosine deaminated to uracil. Only if amino group is there, it can be deaminated. So the top of this particular molecule is having an amino group, and then deamination happened. This amino group is removed. So when amino group is removed, you can have a double bond O. There is no change between U and thymine other than the methylation. So this also will have a double bond O here. Now the question is where this methyl group is added. Methyl group is added at this particular position, CH3. So this becomes the fifth position of the thymine. So thymine is otherwise known as the 5-methyl uracil. Now you have to balance, you have to make up the valency. So this particular carbon is now having only 3 bond filled. So 1 is remaining. Nitrogen 3 bond already filled. This carbon 4 bond already filled. And this nitrogen 1 bond is remaining. You can have a H here. And this particular carbon, there is no possibility for the double bond here. So you can have a NH here. And then still only 3 valency is filled, so it will be having double bond and then H. So after adding this NH2, double bond O and double bond O, you have to think about filling the valency. The first rule is in the first position double bond. If it is not possible, then hydrogen. If it is not possible, then in the second position hydrogen bond. Just like think about this here. So here double bond, first position double bond is not possible in order to fill the nitrogen 3 valency. So next chance is hydrogen added to nitrogen. So you have added hydrogen. So it is filled. Now in the same way, in this particular carbon, so here there is no possibility for the double bond because nitrogen valency is already filled. So you have added hydrogen, and after that still only 3 valency is filled, so you have to add a double bond in the next position. So you have to follow this particular rule. All the remaining will be same only. So you cannot add a double bond here, so you are putting hydrogen. So this double bond is filled up. You cannot fill double bond in order to make up the nitrogen valency. So hydrogen added, then hydrogen, hydrogen, double bond. So the same rule you have to follow so that you will not be remembering the structure, instead remembering the fact about the structure. So that's about the pyrimidine. Now you have a purine structure. Purine, you have two purine, adenine and guanine. Anyway, all the purine is having the first ring, which is similar to pyrimidine ring. And the second ring is a 5-membered ring, having a nitrogen here, having another nitrogen here, and then the same ring you can represent for the next purine. Okay, here first one is adenine and then guanine. Adenine and guanine. So you have to remember which of this molecule is having on top amino group. We can see that A is here for the adenine. So A and amino is relating. So you have to relate that and you can put amino group on top. So here it will be double bond O. Now there is no deamination is happening when adenine is converted into guanine. So instead this amino group is changing the position. So this amino group will be moving and it will be attaching to the next carbon. So from here it will be attaching to the next carbon. So it will be having NH2 at this particular point. Only this you have to remember. So there is no double bond O here, just like the case of pyrimidine. Only this thing you have to remember, and then valency can be filled up. Here double bond is possible, so you have put double bond. Here there is no possibility for the double bond because nitrogen is filled up. Now you can put hydrogen and then a double bond. Then only the carbon valency will be filled up. So this nitrogen, there is no need of addition of hydrogen because already it is filled 3. Now you have one double bond here. And then you have to anti-clockwise, always move in anti-clockwise. So there is a hydrogen possibility here. And now there is no double bond possibility here. So you have to put hydrogen first and then double bond. So the same structure will be applicable. Instead of double bond here, it is already having double bond. You can have a hydrogen here. And then double bond, double bond, double bond, hydrogen, hydrogen. So these are the structures of adenine and guanine.